pH equals 1.376 times 10 to the 10 years, which we can express in terms of billion years, 13.76 billion years. So the oldest that our universe can be is 13.76 billion years. Oftentimes in graphs you see, when you read a cosmology book or some book about the Big Bang, you see this graph. And this would be the graph of the time, and then this would be the graph of the size of the universe. Size of universe. And it says, presently we are here. Okay, this is now. This would be the size of the universe, the expansion of the universe, if there was no such thing as gravity. The Big Bang happened, the thing would expand, the universe would expand uniformly, and there would be nothing pulling it in, nothing pushing it out, and it just would go constant rate. Okay? So if the present is now, the time from the origin all the way to now, that's the Hubble time. It's the inverse of the Hubble constant. So we just discovered that that's 13.76 billion years. Okay? If the universe has a gravity and the Big Bang happens, and so now gravity is slowing things down, gravity is pulling things back down, okay? Then you have different options of what the universe can be. It could be either a closed universe, an open universe, an accelerating universe. So you have graphs that look like this. This is a closed universe, and therefore the universe goes, and may one day reach a most biggest possible that it can be, and then recollapse, and then maybe it will expand again. So this would be an oscillating universe. So what would be the age of the universe for a closed universe like that? Okay, it ends up, when we do the math, that the age for a closed universe would be less than 2/3 of the Hubble time. Okay, less than 2/3 of the Hubble time. 2/3 of the Hubble time comes out to be about 9.18. 9.18 billion years old. So one way we can test. So one way we can test whether or not which model of the universe is correct is to go look for different things in the universe and try to see what their age is. And if we can find something older than 9 billion years old, then that will already make this model of the universe invalid. So this is the closed model. Okay? Then there's the marginally bound model. Goes like this. This one is also, the closed model is also called bounded universe. Okay? So then there is the marginally bounded. Marginally bounded. That means that's a universe that the acceleration takes place and there's still gravity, but there's enough velocity for it to never stop expanding. So the universe kind of slows down, but never quite stops and returns back. Okay? So that's marginally bounded. The time for the marginally bounded, the age of the universe comes out to be exactly 2/3 of the Hubble time. So exactly 9.18 billion years old. Okay, so for the bounded model, it's less than 9.18 billion years. For the marginally bounded, it's 9.18. Then there's the unbounded, which is like this. Okay, unbounded means it just keeps expanding and it never even reaches a velocity of 0. Okay, that means it's faster than the marginally bounded. The time is greater than 2/3 of the Hubble time, which is greater than 9.18, okay, billion years old. Then the other model is the accelerating model. The graph for that looks something like this. Looks like this, and then at some point it takes off and begins accelerating, okay? So the time looks kind of like this. The time for the accelerating model is the largest. So t for accelerating is greater than the t for the unbounded and less than t Hubble. So the accelerating time of the age of the universe can be as old as 13.5 billion years old. Not exactly as old as the Hubble time, but very close to it. So according just to that argument, that would favor the accelerating model of the universe, because we have discovered things that are way, way old as 13.5 billion years old, 13.2, 13.3 billion years old. So that would lead us to believe that the accelerating model of the universe is the true model of the universe. See here from this video that I wanted to concentrate on what is the meaning of the Hubble constant, how is Hubble time related to that, and how can we show that the Hubble time is actually a unit of time and that it's actually equal to something close to in the vicinity of 13 billion years old. Thank you very much. Bye.